All right, so in this lesson we have 1.6 math and logical operators. Now we've already learned a little bit of how to do math with arithmetic operators, our addition, subtraction, things like that, but we're going to get into those a little bit deeper today. So for starters, let's talk about the built-in math that's available in C++. And when I say built-in, I don't mean, again, the arithmetic operators. I'm talking about the built-in functions. So here's two. All right, the two most important ones we're going to look at. The first one is max. So it returns the maximum from two numbers, and it accepts int and double types. Now, when I say int and double types, I'm talking the integers and the decimals. So there's more than one type that gives you just integers, right? There's short, int, long, and then there's more than one type for double. Those all have varying support, but int and double will guarantee to have support here. And those tend to be the most common use. So this x and this y could be a 3 and a 4, or it could be a 3.5 and a 4.5, right? Either of those are acceptable numbers, okay? And this function will return the larger number. So if I send x as a 3, y is a 10, this function will return a 10. Now, min does the exact opposite. Min returns the minimum number from two numbers, and it accepts int and double types. Now, the next thing, and this is a lot more than the built-ins, these are the ones that are not built in, okay? This comes from cmath. So here we have another include. If you include the cmath header, okay, we get access to all of these functions. These 9 functions here. Now, there are more. In fact, there are a lot more functions that you can get with cmath, but to me, these are the ones that you will be using the most as a beginner. So let's dive into let's briefly talk about these, okay? So POW stands for power, and your x would be the base and the y would be your power. So if x was 2 and a y was 5, this will return 2 to the power of 5. And again, ints and doubles. Square root will return the square root of a number. So square root of 16 would be 4. This would return the cubed root. And all three of those take ints and doubles. That's important because this fourth one here, round, does not take ints because you can't round an int, right? Well, at least when we refer to round, we're talking about rounding decimal places, not, ones, tens, and hundreds, right? But here, whatever number we send, it's going to return the nearest int, and it only takes double types. So if I send, 3.1245, it's going to return a 3. If I sent a 4.5, it'll return a 4. It's going to return that nearest whole value. In a way, it's kind of just cutting off the decimal. Now, sine. We have sine, cosine, and tangent, and these are done in radians, okay? And you can send int and doubles. And then we have log, which returns the natural log. So there are other ones that can do different types of logs, but this will only do the natural log. And then we have absolute value, which will return the absolute value of whatever number you send it. Okay, let's see what this looks like when we actually code it. Okay, let's talk about the built-ins first, okay? And one thing I forgot to mention in the slide is that your max and your min functions, these built-ins actually come from the standard namespace, okay? So I normally would put, we would put std, put our scope right here, but we did learn in the previous lesson that we can use using namespace, and that alleviates us from having to do this, okay? But you again, need to know, where do these things come from? Where are they built in? They're built in the standard library, okay? All right, so let's push a little further. We have max of 5 and 3, which should return a 5. We have a min of 3.5 and 6.5, okay? Now, when I go to run this program, you should see, nothing happen, right? And the reason why nothing happens, we haven't done anything with these values. We called these functions They returned the number, but we didn't do anything with them. So we have two choices of what we can do. We can store that answer. So because I sent in two ints, I'm going to use an int, an int maxi, I'll just call it maxi. And then this would get restored into that variable so that I can do something with it. And then here I have doubles that I'm using. So, silly names, right? And I'm going to store the result of this, the minimum, into double max. And then I can do something with that. So I can see out and print out both those values. Okay. Wow. I named those the wrong way. That should be min. Okay. So let's give this another run. And we compile and good, right? We got the maximum number. We got the minimum number. All right. Now, we don't have to always do it this way. Okay. So you can see here, we took this, we stored it in there. But if we want to, we can just call this inline anywhere we need to. So let me put this one right there, and then I'll have to delete that line. Okay. So I'm calling it where I'm printing it out to the console. So I compile, run, and I get the same exact output. Either of those is fine. The one big thing you have to be careful of with these is you can't mix the data types. So you see an int and an int. Okay. But now I have a double and a double. If I do an int and a double, I should get a compile time error. And that's exactly what I get. Okay. Conflicting types for parameter. Okay. So you need to make sure they're the same exact data type in order for that to work. Okay. Now, the next thing I showed you guys was cmath. Now, cmath is going to bring in a lot of additional features. I'm not going to show you all of them. All right. And the reason why I'm not going to show you all of them is you need to learn as a beginner coder how to look at documentation and run that code without always seeing it done. Okay. So in the slide, I said that, this function takes doubles and ints and it takes one value for X. Okay. So that's enough to go, I can send it that value. It should give me the square root or whatever function you're calling and get them. Now I will model some of them, but not all of them. Okay. Now in order to use this, we have to go back up and we have to include the cmath header. Okay. In order to get all this functionality. So let's do some powers, and I'm just going to go and print these out. These work just like up here. When I call a function, it's going to return it, but I'm going to, instead of storing it and then printing it, I'm just going to go ahead and print it. So let's do the power of, 2 and 5. So that should do 2 to the power of 5. I run that. What do we got here? Oh, it's POW. That's right. It's just POW for power. And we run it, we get 32, exactly what we should get. Okay. And you should be able to put decimals in here, and you should be able to mix those up just like that. Perfect. Okay. So that, needing the same data type was really for, min and max. Okay. Now we also learned about things like round. So I can send it, a 3.14. And it rounds to 3 like it should. Okay. And let's do another one. Let's do square root. So see out square root of 16, which should give us 4. And it does. Okay. Now, if you notice a theme here, when I wrote that documentation in the slides, for power, I put an X and then a Y. Okay. It needed 2 pieces of information, or what we're later going to learn is called arguments. This function called, POW for power takes a 2.5 and a 5, 2 arguments. Now round, square root, sine, cosine, tangent, all these other functions that we saw, we just put a single X. So that tells you that you need to send a single value. Okay. So when you're looking at that documentation, how do I run this function? Call its name, give it a value. Did you have to send it a raw value? Could you have made a variable? Absolutely. Either of those would have worked just fine. Okay, here we have logical operators. And I thought long and hard about, do I introduce these along with if statements? And it just kind of seemed to be way too much on if statements, right? Because when we learned them, you had to focus on ifs and else ifs and elses, and then Boolean conditions and, other types of operators. And relational operators. It just seemed to be a lot to also throw in logical operators. So now that you've had a couple lessons with if statements, we're going to bring these back in, okay? There are 3 logical operators: the and, the or, and the not, okay? Now, you have 2 ways of referencing them. That's why I have an example on the left and an example on the right. The example on the left is still seen everywhere, okay? And in a lot of language, it's still the only way you can actually represent them. And if you're looking at legacy code or, just even new code, you're going to see these operators because it's just been used forever. Now, more modern languages sometimes tend to use the word instead of the symbol because they're not far off, okay? So here, if we use double ampersands, which is on the 7 key, so shift 7, then you're saying that you're grouping these conditions into an and relationship. So what is an and relationship? An and relationship means that both of these conditions must be true in order for this whole statement here to be true. If just one of them is false, then this whole thing evaluates to false. So let me give you an example. If I had the number 15, 15 is greater than 10, and 15 is less than 20. That is true and true. So because both of those statements are true, I get a single true out, and then this runs because I'm looking for if true, do this, right? Now let's run this again. If A was 25, 25 is greater than 10, true, and 25 is less than 20, false. So because we just have one false here, all of this evaluates to false. Therefore, this if statement doesn't run. So we'll go to the next one because it's an else if. So then here we have the double. I don't even know actually what these are called. I just call them lines, vertical lines. And if you look below your delete key and above your enter key, you should see these. You have to shift that key. I don't even know. That's the backslash key. Shift backslash should give you these. You need 2 of them. And this means or. Okay. Now an or relationship saying one or the other needs to be true. Okay. So here, look, we have B is greater than 10 or B is less than negative 10. You can already see off the bat that both of those cannot ever be true, right? Because we're talking about completely different ranges of number. So, if I said 15 for B, 15 is greater than 10, or 15 is less than negative 10. Well, the first one's true. The second one is false, but this is an or relationship. An or just needs 1. So because this one was true, this whole thing evaluates to true. Okay. So then that would run. All right. Now they both can be true. That's fine. But as long as one is true, it'll run. The only time this won't run is if both of them are false. Okay. Now this last one is called not. And not doesn't have a different way of doing it. That's why it's pointing to the same exact thing for both of them. So not is an exclamation equal, and we're saying it, it does not equal. Okay. So we're saying C does not equal 10. If that's true, run this. And so that's a ton of numbers. That's every number but 10. 11 and beyond, 9 and below would be true here, right? 9 does not equal 10, true. 8 does not equal 10, true. So that would run. The only time this wouldn't run is when C is 10, okay? Now to quickly look at these, and or are replacements, okay? It doesn't bother me which one you use. Use whichever one makes you feel better. Most people nowadays tend to go with the words, okay? But you still will need to know these symbols, all right? So use whichever one you want, but don't forget about these, okay? Because it's everywhere, all right? Okay, let's look at a couple examples. Let's get this running so you can see what. So I already have these examples set up for us, almost, okay? The last thing we need to do is get input, okay? But I wanted to set this up already so we can just jump into talking about it. It's almost the same exact thing as what you see in the slides, except for I got rid of the else ifs and did just if statements so that I can get all three of those inputs at the same exact time, okay? So I'm gonna go C out, I'm gonna say enter 3 numbers. Now before you did this, you might have had to write 3 separate C ins, okay? I'm going to show it to you a little bit differently this time. Now, if this one confuses you, it's okay to table for now, but it might be something you find very helpful when getting multiple inputs. So I'm going to go C in, and I'm going to go A, and then I'm going to extract again and go B, extract again and go C. So now we're saying if there are 3 pieces of information entered in, put the first one in A, the next one in B, and the next one in C, okay? So let's test to see what prints out here. So let's compile this, run it, and I'm gonna go, let's see, I'll go 15 space, okay? Because now, look, this is a single input. So I'm putting all 3 of these in at the same time, but I'm separating with a space so it knows to, which one goes to A, B, and C. I'll do a 15 for B, and I'll do a 10 for C, okay? So look at this, all right? A is between 10 and 20. That worked, right? We said that if A was 15, both of these conditions were true, therefore that if statement would run, right? Because 15 is greater than 10 and 15 is less than 20. We saw that B ran because B was 15. B is greater than 10. That was true. Or B is less than -10. That was false, but that doesn't matter. Only one of these needs to be true because it's an or relationship. And then we saw C did not run at all. Okay, we put in the number 10 for C, and C does not equal 10. So that was, 10 does not equal 10 is a false statement, right? So that didn't run. So let's do it again so you can see C run, and then let's do a couple situations maybe where A or B doesn't run at all either. So I'm going to rerun, and let's do 25 for A. Let's do 0 for B, and let's do 9 for C. And look at this. The only one that ran this time was C. I can see that 25 is greater than 10. True. 25 is not less than 20. False. Doesn't run. It's an and relationship. They both need to be true. Or, right? I got 0. 0 is greater than 10. False. 0 is less than -10. Also false. The only time an or relationship won't run is when they're both false. And then finally 9. 9 does not equal 10. True. So C must not be 10 prints out. Okay. So, these 3 operators are going to be super useful. And the calculator app the grade checker one that you did, this would have been really helpful to know, but it was okay that we didn't know at the time. Now remember, you can swap these too. So I could put and I could put or. And when I recompile and run this, I could do 15, 15, I think 10 was the first numbers we put in, and everything's going to run exactly the same. Those are totally okay to do. And then the last thing, I just want to recap on this, okay? What many of you would have done up to this point is you would have done this. Okay, you would have done, you would have done a CN to go to A, you would have done a CN to go to B, you would have done a CN to go to C, and the user would have had to enter in 3 separate times, okay? There's really nothing different about this, okay? At this point in time and what you know with coding. This is a preference choice at this point. If you feel better having them enter in 3 times, go for it. If you want to be able to do it all on one line, go for it. But the margin of error is a little bit more when you're doing it all on one line. A regular user might not know to enter in spaces in between their numbers. So you might want to say enter 3, numbers separated by spaces if you chose to do that method, okay? You always want to kind of make sure that the user can't crash your program, all right? So keep that in mind, preference choice. Okay, here's the last quick code before we work on a lab. Okay. Now this quick code is a second calculator. And I know calculator is a big theme early on, and it is because it helps us, teach us a lot of the tools that we have available. Now this one's going to be a little bit more advanced than the last one you did. It's not going to include any of those arithmetic operators. We're going to do more of the cmath operators. Okay, so your calculator, I believe, should do either 8 or 9 functions. It needs to be able to do the absolute value, the square root, the sine, cosine, and tan. Now the user will be entering those in radians. So if you're trying to make sure it's all working, know that it's in radians and not degrees. But for the purpose of this program, just taking an int or a double, putting in it is fine. It should do the cubed root. It should do the exponent and round and power. So I'm just realizing that exponent and power, those are the same thing. So don't worry about exponent. You should do round, power, and log. All right, so let's recap that. Absolute value, square root, sine, cosine, tangent, cube root, round, power, and log. So that is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, excluding exponent because it's the same thing as power. Okay. It should have those 9 features, and your calculator should present to the user what options they can choose from, and then ask the user for their inputs after that. Because if you notice, power needs 2 inputs. The rest of those need just 1. Okay. So we need to be able to make sure we can get a different amount of inputs from the user based off of their choice. Now there's a couple ways to do this when asking the user. You can have them enter in a word, right? You can be like, what operations do you want to do? And they can say absolute, but the more you make a user spell, the more chances of error they have. Okay. So in the example program I'm going to show you in a second, I just simply, said enter 1 to do this. Okay. Okay, so I wrote a quick program. It doesn't include all of the features that yours is supposed to include, but it includes 2 of them. Okay. So when I run this, you can see, look, welcome to my super cool calculator. Here are your options. Enter 1 for absolute value, enter 2 for power. It's not mandatory that you do it that way. You can be unique on it. Okay. And then, I put here, your program will have many more options. You need 7 more. Okay. So I'm going to enter in a 1. And so I just told the program to choose absolute value. So now look, after I made that decision, enter in the number you want to find the absolute value of. Notice how, look, I'm even including the operation name, right? So I'm not just getting inputs at the beginning of the program and then hoping to do things with them later. Okay. Here we're getting much more specific. So enter the number you want to find the absolute value of. I'm going to put -10, which should just give us the number 10. Awesome. Okay. Now let's run it again. Enter 2 for power. Notice this. Enter in 2 numbers you want to power because that is different, right? And then base, then power. You want to specify that so they know which order. So I'm going to go 2 and then 5, which will give us 32. Okay. Now I wrote this program to be ints only. It is your discretion to choose if you want ints, if you want double support. It's not so important that it can handle all that stuff right now. It's more important that you learn how to call in these built-in functions. Okay. So I hope you enjoyed this video, and I will see you next time.